Dear students, in the previous classes, we have discussed what is Nash Equilibrium and also what is dominant strategy equilibrium. In the present class and also in the succeeding classes, we will discuss a few examples of Nash equilibrium and also dominant strategy equilibrium. We have explained the concept of Nash equilibrium with the prisoner's dilemma, the most famous of the game theories. Now we consider a few economic examples. We start with the dominant strategy equilibrium. Dominant strategy equilibrium, that is a strategy which is the optimal strategy for a player, irrespective of what the opponent does. We explain this with an economic example. We have two firms, firm B and firm A. Two strategies: advertise, don't advertise. For firm A also, advertise, don't advertise. The payoffs are 10, 5, 15, 0, 6, 8, 10. So assume that firms A and B are selling competing products or differentiated products, substitutes, and are planning to decide and are planning to make a decision about whether to advertise or don't advertise. And while taking a decision, each firm take into account its competitors while deciding its own strategy. The question is, which strategy each firm will adopt, given that the competitor will react to any strategy adopted by the competitors. Now consider firm A. Now, if A assumes that B will advertise, A will get a payoff equal to 10 if it advertises, 6 if it don't. So if A assumes that B will advertise, better for A to advertise. Similarly, if B don't advertise, A advertise, A will get 15. If A don't advertise, it will get only 10. So it advertises. So for firm A, it is always better to advertise, irrespective of whether B will advertise or not. So we will say that advertise is the dominant strategy for firm A. advertise is the dominant strategy for firm A. What about B? If B thinks that A will advertise, if B advertise, it will get 5. Don't advertise, only 0. 5. If B thinks that yes, don't advertise, it will get 8 if it advertise, 2 if it don't. So firm B has a dominant strategy. Irrespective of whether A advertise or not advertise, it is better for firm B also to advertise. So we will say that both the firms have the dominant strategy, advertise. Both the firms have the dominant strategy, advertise. So in this case, it is easy to determine the equilibrium as both the firms have the dominant strategies. And as we have discussed earlier, if a firm has a dominant strategy, it will always adopt its dominant strategy. So when every player has a dominant strategy, we call the outcome of the game an equilibrium in dominant strategies. An equilibrium in dominant strategies. In this case, the equilibrium is both the firms will advertise. A will get a payoff equal to 10. B will get a payoff is equal to 5. So, in this example, it is easy to determine equilibrium. The reason is both the players have dominant strategies. And if a player has a dominant strategy, it will always adopt that strategy. But unfortunately, every game will not have dominant strategies. Every player will not have dominant strategies in every game. To see this, we modify the payoffs given by this game. We modify the payoffs. Again, firms A and B, the strategies are advertise, don't advertise. This payoff are same. I modify this as 22. Modify the payoffs as 22. Now let us see. If A believes that B will advertise, A 10 by advertise, 6 don't. So 10 if it advertise. If A believes that B don't advertise, A advertise 15, don't advertise 20. Now we will say that A has no A has no dominant strategy. Its optimal strategy depends on what B does. It's optimal, that is, if B advertise, it is better for A. If A advertise, it will get 10. Don't advertise, only 6. So if A believes that B will advertise, it is better for A to advertise. If A believes that B don't advertise, if A advertise only 15, don't advertise 20, so better for A to don't advertise. So the optimal strategy of A depends on what B does. If B advertise, A does best by advertise. If B don't advertise, A does best by don't advertise. Now the question is, if both the firms take the decision at the same time, what A will do? What A will do. To answer this question, A must put itself in B's shoes. A must make an analysis about what B will do. Now consider B. If A, B believe that A advertise, better for B to advertise, because it will give if it advertise 5, otherwise 0. If B believes that A don't advertise, it will get 8 if it advertise, 2 don't. So B has a dominant strategy, that is advertise. Whether A advertise or don't advertise, firm B has a dominant strategy. The strategy is advertise. So A can conclude that B will advertise. A can conclude that B will adopt its dominant strategy and advertise. And if B advertise, better for A also to advertise. If B advertise and A don't advertise, it will get only 6 instead of 10. So as B has a dominant strategy, and if A believes that B will adopt its dominant strategy, it is better for A to advertise. So both the equilibrium is both firms advertise. Both firms advertise, and A will again get a payoff equal to 10 and B will get a payoff equal to 5. Now the thing is, in this game, as against the first, A is doing the best it can, given what B is doing, and B is doing the best it can, given what A is doing. In the first example, in the context of dominant strategies, each firm is doing the best it can irrespective of what its competitors are doing. But in the second example, each is doing the best it can given what its competitors are doing. This is the concept of equilibrium which we have discussed earlier. That is, while discussing the concept of equilibrium under oligopoly setting, we have modified the concept of equilibrium as, in equilibrium, each firm is doing the best it can given what its competitor is doing. And remember this, in the first example we have considered, there was dominant strategy equilibrium, and as we have seen, dominant strategies are stable. When we define equilibrium, it must be remembered that once the equilibrium is achieved, it must stay there. Once an equilibrium is achieved, it must stay there. That means the firms will not have a tendency to deviate. In the case of dominant strategy equilibrium, as in the case of prisoner's dilemma also, neither firm A nor firm B has a tendency to deviate, because deviating from the equilibrium strategy is not beneficial to either firm A or firm B. So the question is, as we have seen, dominant strategies will not be forthcoming in all cases. If there is dominant strategy, the equilibrium in dominant strategies is stable. But the problem is, the dominant strategies will not be available in all cases. So we require a more general concept of equilibrium, and this is given by Nash equilibrium that we have discussed in detail. is a Nash equilibrium is a set of strategies such that each player is doing the best it can given the actions of the opponents. Each player is doing the best it can given the action of its opponent. So consider this. This is an equilibrium not in dominant strategies. This is an equilibrium in Nash, or this is an example of a Nash equilibrium. Also, suppose that both firms are advertising. If B continue to advertise and A don't, that is, if it deviate from advertise to don't advertise, its payoff decreases. Similarly, if A advertise, B also advertise, and B changes its strategy to don't advertise, its payoff decreases. So here also the strategies are stable. So in this example, the Nash equilibrium is both firms advertise. Both firms advertise. But this is not an equilibrium in dominant strategies. This is an example of Nash equilibrium strategy. That is, each firm is doing the best it can given the strategies adopted by the rival firms. And remember this, it is a best response to best response. It is not a best response to all the other strategies of the rivals. All the other, if a strategy is the best response to all the strategies of the rivals, it is dominant strategy. But in this case, B has a dominant strategy, but A has no dominant strategy. But it is a Nash equilibrium strategy. And remember this, while discussing the oligopoly models, we have used the concept of Nash equilibrium to study the price and output decisions of oligopoly firms. For example, in the Cournot model, each firm sets its output taking into account the output decision of its competitors. And once the equilibrium is achieved in the Cournot model, neither firm A nor firm B has an incentive to deviate. So Cournot model is a stable equilibrium with each firm doing the best it can given the action of its competitors. Likewise, in the Bertrand model, each firm fixes its price taking its competitor into account, and the equilibrium price obtained in the model is Nash equilibrium, and neither firm A nor firm B has an incentive to change or deviate from the equilibrium price. So remember this, Nash equilibrium is different from dominant strategy equilibrium in the sense that in the case of dominant strategies, each firm is doing the best it can given what its competitor is doing. Each firm is doing the best it can irrespective of what its competitor is doing. Nash equilibrium means each is doing the best it can given what its competitor is doing. And Nash equilibrium, dominant strategy equilibrium is a special case of Nash equilibrium. Means dominant strategy is automatically Nash equilibrium because dominant strategy is a special case of Nash equilibrium. But Nash equilibrium is a wider concept. It includes dominant strategy equilibrium as a special case. And advertising, both firms advertise, is Nash equilibrium, but not a dominant strategy equilibrium. When this payoff has been changed from 10 to 20. In the first case, it was Nash equilibrium. It was also dominant strategy equilibrium. Now, in general, as we have discussed earlier, a game need not have a single Nash equilibrium. And that means some games will have more than one Nash equilibrium, as we will see. And sometimes there is no Nash equilibrium in pure strategies, but there will be a Nash equilibrium in mixed strategies, we will see. Sometimes there will be several Nash equilibrium. But the advantage of Nash equilibrium concept is there will be at least one Nash equilibrium in all the games. Whereas you need not get Nash equilibrium, equilibrium in dominant strategies. Now, to further explain, let us consider a few more examples. Another example that we consider is product choice. Product choice problem. Product choice problem. Now, the problem is two breakfast cereal companies face a market such that each firm can make profits if it introduces each firm face a market in which each firm can introduce a new variety profitably. Or stated differently, there is a possibility for introducing profitably two varieties of breakfast cereals, crispy and sweet. Two breakfast cereals, crispy and sweet. So two new varieties can be introduced profitably. But the problem is, if both firms introduce crispy or sweet, both will lose money. -5. Both sweet, again -5. If both introduces the same cereal, crispy or sweet, both lose money. That is, it is profitable to introduce only one variety. Profitable to introduce only one variety, not two varieties. Now, if firm A introduces crispy, B sweet, both will make a profit of 10. Here also 10. Now let us see what is the equilibrium here. If A assumes that B will introduce crispy, then if it introduces crispy -5, otherwise 10. If A assumes that B will introduce sweet, then it crispy 10, sweet -5. If B assumes that A will introduce crispy -5, sweet 10. Sweet, crispy 10, otherwise -5. So both entries are underlined here. Both entries receive underline here also. So we have two Nash equilibrium. The question is, if both firms are taking the decision at the same time, which equilibrium will be reached? That we cannot say. The point is, both are equilibria because once this or this is achieved, neither B nor A have an incentive to deviate. For example, if A is producing sweets and B produces crispy. If it changes to sweet, it loses money, -5. Similarly, if B is producing sweets and A changes to crispy, again it loses money. If both of them are producing sweets or crispy, both will make profit. So neither A nor B has an incentive to deviate. And we cannot say whether they will reach this equilibrium or this equilibrium. What we can say is, once either this or this equilibrium is achieved, neither B nor A has an incentive to deviate. That is all what we can say. And one limitation of game theory is, as we have discussed earlier, we cannot say how a particular equilibrium point is achieved. In the Cournot model, equilibrium is determined by intersection between the reaction groups. Whether they will reach the equilibrium or not, or how they reach the equilibrium, the model is silent about that. In the same way, in this game, A produces crispy, B sweet, or A sweet and B crispy, we cannot say, because decisions are taken at the same time. But once reached, neither firm A nor firm B has an incentive to deviate. So it is Nash equilibrium. To get information about whether they will reach this or this equilibrium, we require more additional information, or by an advertisement or something. If B is expressing his intention to produce sweets, then A can produce what is known as intention to produce sweet, A can produce crispy, and vice versa. Otherwise, we cannot say how this particular equilibrium is actually achieved. As a further example, let us see one more example. This example is the beach location problem. This example is the beach location problem. Suppose that two sellers are selling soft drinks in a beach having a length of 200 yards. Having a length of 200 yards. Suppose also that the tourists are evenly spread in the entire beach. Suppose also that they will purchase from the nearest seller. Then two sellers, A and B, the length of the beach is 200 yards and tourists are evenly spread throughout the beach, and they will purchase the soft drinks from the nearest seller. Now the question is, what is the Nash equilibrium here? The Nash equilibrium is both A and B will stand in the center. A and B, like this. Thinking that C is here. In the other side, there is C. The question is why? So suppose that B is standing here. Then tourists from this point up to this will purchase from A. B will get only tourists in this region. So naturally, B has a tendency to move. So if one seller has a tendency to move from the present position, it is not a Nash equilibrium. Similarly, this is not also a Nash equilibrium. Again, you have the same problem. So the Nash equilibrium is both the sellers will stand in the middle of the beach so that he can sell, or the tourist will purchase from A and also from B. So in the case of this beach location problem, the equilibrium is that both stand in the middle of the beach. That is the only Nash equilibrium in this example.